Good. Welcome back to my YouTube channel. Today we are going to look at number system. Number system. You know, all these days we have been looking at numbers. So we want to look at the system of numbers today. What is system of number? We have a lot of number system which we use every day. For instance, we have been looking at number system of denary, that is decimal, base 10. So today we want to look at other bases, but we are going to focus on the computer use of number system, which are the binary, the octal, decimal, and hexadecimal. This is our focus. And of course, we solve some problems in other bases. Okay, let's get started. I told you we have 4 basic number system used in computer for machine learning. For those of you who use computer, you understand it's called machine learning in computer. But of course, in mathematics, we have a lot of bases. But we're going to look at these 4, and later we'll look at others with a sample. Okay? The one we used to is decimal. Decimal number are digits within the 0, from 0 to 9, right? So we have 0, 1, 2, up to 9. These are a sample of decimal. Some textbooks call it denary. So numbers from 0 to 9 consist in decimal number. Now, come to binary. Binary number consists of 0 and 1, because this means base 2. That is, you count 0 and 1, the number that is not up to 2. This one is base 10. The standard base we use every day to calculate money in bank, in markets, and so many places. Base 10, we count in 10. That's why the highest number we can have here is 9. So it starts from 0 to 9. If you count this digit now, you will see that it was 10. Octal means 8. Base 8. And base 8 consists of 0, 1, 2, up to 7. And their father, hexadecimal. Hexadecimal is another word for base 16. Base 16, which consists of 0, 1, 2, up to 9. And now we have 10. You know, we need to have number up to 15. So instead of having 15, right in 2 digits, we use letter to represent it. So instead of 10, we have A, B, C, D, E, and F. This A means 10. This B means 11, C 12, D 13, E 14, and then F is 15. So these are the number consists in hexadecimal. So if I ask you now, what are the number consists in base 4? In base 4. Base 4. It means it consists number up to 3. Right? So we have 0, 1, 2, and then 3. This base 4. If I say solve the problem in base 12. Base 12 means you stop at 11, right? So instead of having 10, we have A and B, and so on. So this is very important. If it's base 7, which means you count up to 6. So when you get to 6, you stop and you start counting from 0 again. There's some markets that they count in 5, right? There's some markets that count in 5, like that's what we did in our last video when we deal with modulars. we count our wristwatch, we count in 12, right? We count in 12. When you get to 12, we start counting again from 1, right? Also, the days of week. We have 7 days in a week, right? When we count from Sunday up to Saturday, we stop, right? We start counting again from Sunday to Saturday, we stop. So this is base 7, right? Because we have 7 days in a week, right? So you count in base 8. So you count in numbers of days. Also, months. We have 12 months in a year. It means when we count from January to December, we stop. We start counting again from January to December, we stop again. This is big. So this is what we use every day. We use it every day. And now let us see the approach mathematics gives to it. So our aim is to see how to convert base 2 to base 10 and how to convert it back. Base 8 to base 10 and how to convert it back. Base 16 to base 10 and how to convert it back. Why base 10? Because base 10 is the common base we use every day. Of course, you can convert from base 2 to base 16. It's possible. You can convert from base 8 to base 2 and vice versa. Or base 16 to base 8. You can play around like this. Okay? I'm very sure we are going to enjoy this class. Okay? Now, let's start. Very warm level. You ready? Let's get it started. Good. Now, let's start with conversion to decimal. So we want to move from order basis to decimal. From base 2 to base 10, from base 3 to base 10, 4, base 10, 8, base 10, 9, base 10, 12, base 10, 16, base 10. All the points we want to go to base 10. Why? Because base 10 is what we know before, right? So we want to go how to move from order basis to base 10. Okay, let's start. The first example, how to move from binary, which also known as base 2, to decimal. To move, we have to start counting. What we have here, we have, let's write solution. We have 1, 0, 1, 1, 0 in base 2. The base will be substitute. Okay, in base 2. So you start counting from the last number. The digit number is from 0, 1, 2, 3, and 4. Right? This is the number, this is the base, and this is the power. Now, we start solving the problem. Pick the first number. The first number is 1. Multiply it by 2. This one is carrying 4. This guy belongs to this. This expression is what we know from decimal number. Do you remember? From decimal number. When we do expansion. If you don't remember, please check our video for more detail. Okay? We are expanding with 2. In that place, we expand with 10. Good. Plus, the next is what? Is 0. So we pick 0 times the base. 0 is carrying what? It's carrying 3. Next, 1 times 2, power of 2. Next is 1 again, times 2, power of 1. And the last is 0, 2, power of 0. This is the number, this is the base, and this is the power. And you know power, exponents, right? Index. Remember? Previous video, it doesn't help you. So quickly, to solve this kind of problem, we have to use big maths, right? Or board maths. Exponents before multiplication. So we have 1 times 2 to the power of 4. It means 2 in 4 places, right? That is 2 times 2 times 2 times 2. Which gives us what? 16. Plus 0 times 2 to the power of 3. It means 2 in 3 places, right? So we have 8. 1, 2 in 2 places is 4. 2 in just 1 place is 2. And 2 to the power of 0 is what? Go to the law of exponent. Mathematics is foundation. If you miss it, you have to go and recover it. So if you miss the law of exponential or law of indices, please go and check it. Anything to the power of 0 is 1. I mean, at this level. Very soon we prove that it's not possible. Okay, now we have solved the exponents. Now we can go to multiplication, right? So 1 times 16, 16 plus 0 times 8, 0, 1 times 4, 1 times 2, 0 times 1. So finally, we can sum it up. 16 plus 0 is 16, plus 4 is 20, plus 2 is 22, plus 0 is 22. So we have 22 in what? In base 10. We have converts, therefore, or ends. You can say 1 is 0, 1, 1 is 0 in base 2 is equivalent to 2, 2 in base 10. And that ends the first question. Do you understand? It's very easy. It's very easy. Just follow the explanation. Follow the explanation. The second question. This is octal. Octal means 8. So octal to base 10. So the same thing, but the difference here is instead of 2, we have 8. But the procedure is the same. So 3, 4, 6 in base 2, I mean in base 8. Counts as usual. 0, 1, 2, and 3. So start picking it. The first one is 3 times the base power of 3. Right? Second one is 4 times 8 power of 2. The next one is 6 times 8 power of 1. And the last one is 2 times 8 power of 0. So without wasting much of time, first perform the power. So I want to do this one at once. 8 to the power of 3 times 6. So multiply it, we have 1, 5, 3, 6. So I don't want to waste time on this, so we can find it out. Plus 8 to the power of 2, that's 64. 64 times 4, that will give us 2, 5, 6. 8 to the power of 1 is 8. 8 times 6 is 48. Plus 8 to the power of 0 is 1. 1 times 2 is 2. Sum everything up. We have 1842 in base 10. So therefore, 3, 4, 6, 2 in base 10 in base 8 is equivalent to 1842 in base 10. Very easy. Let's go to the next question. Hexadecimal to decimal. Hexa means 16. Hexadecimal means 16. So if it's base 16, we want to convert to base 10. The same procedure. Nothing changed. The only thing that is changing here is the base. The procedure is the same. So let's quickly solve it together. 42AD in base 16. As usual. Start 0, 1, 2, 3, 4, 5. We continue until the number finish. And we start picking it. The first is 4 times 16. The power of 3. plus, next is 2 times 16 to the power of 2. Next is A times 16 to the power of 1. The last is D times 16 to the power of 0. Now we have to be careful. What is A in hexadecimal? Okay, pause the video and go back later. You will see that A is what? Is 10. Right? Because after 9, we use A, B, C, D, E, and F. So A is 10. If A is 10, this A is 10 in hexadecimal. B is 11. C, 12. D, 13. So this D is what? 13 in hexadecimal. 13 in hexadecimal. So that's what we are going to use to do our multiplication. So let's multiply. The first one is 16 to the power of 3. 16 to the power of 3. 16 times 16 times 16. Okay. And it's 4 times 4 is 096. You can multiply it out. At this level now, we know how to do multiplication. Plus 2 times 16 to the power of 2. That is 16 times 16. That is 256. Plus A is 10. 16 to the power of 1 is 16, right? Plus D is 13. And any to the power of 0 is 1. So, without wasting much of our time, this times this, this times this, this times this, this times this, you sum them together, the final result is going to be 17069 in base 10, which means 42AD in base 16 is equivalent to 17069. Are we together? Good. The last question. Other bases to decimal. Now, other bases, I just pick base 6. So you can do the same thing. You can try it on your own. Do the same thing with base 3, with base 4, with base 5. But make sure that if you are using base 3, the highest number that will contain in that base should be 2. Don't forget. If we want to solve problem on base 9, the highest number that will contain in any series or number you want to join together must not more than 8, and so on. So this part, four, 2, 0, 5 base 6. As usual, count 0, 1, 2, 3, 4, 5, 6, 7. Coincidentally, we have 3 finished, 3 finished, 3 finished, 4 finished. It doesn't mean that it must be 3, 3, 3. So good enough, we have 4 here. So it can be any number. So please, don't think that it must stop at 3. No. It's just coincidence. Let's pick the number. 4 times 6 to the power of 3. Right? Plus 2 times 6 to the power of 2. Plus 0 times 6 to the power of 1. Plus 5 times 6 to the power of 0. Now, 6 squared, 6 cubed. 6 times 6, 6 times 6, this is 36, this is 18, that is 21, that is 4 times 216 plus 2 times 16 plus 0 times 6 plus 5 times 1, right? Now 4 times 36. 36. Nice observation. 6 squared is 6 in 2 places. So 1, 2, 1, 6 times 4. This is 24. This is 6 and this is 8. So we have 864 plus 2 times 36. That should give us 72. 0 times 6, obviously 0. 5 times 1 is 5. So sum everything up. 864 plus 72 give us 6, 3, 9 plus 0, same, plus 5. That should give us 9, 4, 1. This means 4205 is equivalent to 941 in place. So far, so good. We have solved problems on how to move from other bases to base 10. Now, let's see how to move from base 10 back to other bases. But then this will come to your brain. When you are moving from base 10, other bases to base 10, you multiply, right? So when you are moving back, what is it you do? You divide. You divide. Let's see how it works.